IEI Telangana State Center and convener of the event. Galaxy of eminent personalities, immediate past chairman, past presidents, past chairman, council members, committee members of Institution of Engineers, India, Telangana State Center, corporate members of IEI, family members of late engineer V. Subba Garu, media friends, ladies and gentlemen, good evening to all of you. Today, I feel it a great privilege and honor to be among this August virtual gathering and extend a warm and hearty welcome to the chief guest and all of you to this Engineer V. Subba Rao 5th Endowment Lecture. We are very fortunate to have eminent personality, Dr. MVSS Giridhar, FIE, and we thank him for sparing his valuable time to be amidst this important event to deliver the lecture. I am glad to inform that the Telangana State Center of the Institution of Engineers India has been regularly organizing 18 endowment lectures every year on the birthdays in the honor of the eminent engineers like Engineer V. Subba Rao Endowment Lecture, Engineer M. Tirupati Reddy Endowment Lecture, Dr. J. Purushottam Endowment Lecture, Engineer Koka Krishna Mohan Rao Endowment Lecture, and Engineer G.V. Subba Rao Endowment Lecture, Engineer T. Hanmantrao Endowment Lecture, Engineer A.P. Ranganatha Swami Endowment Lecture, Dr. S. Raghavachari Endowment Lecture, Dr. Narla Tatarao Endowment Lecture, Engineer Matur Gopal Rao Endowment Lecture, Engineer Gurram Kodreddy Endowment Lecture, Engineer Atlur Venkateshwar Rao Endowment Lecture, and Dr. John A. Murray and Dr. N.V.R. L.N. Rao Endowment Lecture, and engineers L. Venkata Krishna Iyer, K.V. Krishna Rao, and M.L. Swami Endowment Lecture, and Dr. A. Ramakrishna Endowment Lecture, and engineer I. Basavaraju Endowment Lecture. The endowment lectures are being delivered by people of high eminence with considerable professional experience to throw light on the important emerging topics of today's relevance. I take this opportunity to brief you about the great engineer, late engineer V. Subba Rao Garu, late Sri SV engineer V. Subba Rao Garu obtained Bachelor of Engineering in 1965, M.Tech in Water Sources in 1982, and M.Tech in Environmental Engineering in 1986. He has attended several training programs, including an orientation program for urban public health engineers at Lara University of Technology, United Kingdom in 1991. Late V. Subba Rao joined Public Health Engineering Department of AP in 1965 and rose to the position of Chief General Manager Engineering and retired in the year 2000. He attended to investigation, execution, operation, maintenance of water supply schemes and sewerage treatment schemes. The credit goes to him for remodeling of the sewerage system of Hyderabad and Secunderabad at a cost of Rs 327 millions and remodeling the existing sewerage treatment plan for Hyderabad at a cost of 43 million and maintaining and operating it. Other important works carried out by late engineer V. Subba Rao Garu include urban water supply schemes for Warangal, Nizamabad, and sewerage of Guntur, and rural water supply schemes in Telangana region in erstwhile state of Andhra Pradesh. His areas of specialization are planning, designing, execution, operation, and maintenance of sewerage systems, wastewater treatment plants, drinking water treatment plants, and modern techniques of measuring and billing for drinking water. He authored the book titled Accounts for Engineers, a Handbook, and published the book titled Tender Procedures jointly with engineer G.L. Rao, FIE, our past president, late engineer V. Subbarao, participated in various conferences and presented papers. He was a recipient of prestigious award, Engineer of the Year in 1997, jointly instituted by the then government of AP and Institution of Engineers India, AP State Center. Took active part in various activities of Institution of Engineers India, Hyderabad. He was honorary secretary of the then AP State Center, the Institution of Engineers India, during the years 1998 to 2000. He also served in Southern Regional Center of Rural Development Forum, Water Management Forum, and Sustainable Development Forum. The Telangana State Center Committee, at its special meeting held on 27th May 2017, has agreed in principle to organize an endowment in the memory of Engineer V. Subbarao, FIE, former Chief General Manager, HMWS and SB, and first Honorary Secretary, Institution of Engineers India, the then State Center, every year, and present a model and certificate to topper of MTech NIT Warangal with the first class for over 2 years in water resources engineering. Today, Telangana State Center has arranged Engineer V. Subbarao 5th Endowment Lecture on the theme Deep Learning Applications in Agricultural Remote Sensing. Since we are anxiously waiting to hear the talk from our eminent speaker, I am limiting myself and hope that you will really enjoy his talk. On behalf of the Telangana State Center of Institution of Engineers India and on my own behalf, I once again extend a hearty and warm welcome to the chief guest and speaker, Dr. MVVS Giridhar Garu, FIE, Professor and Head, Center for Water Resources, Institute of Science and Technology, JNTU, Hyderabad, and all of you to this important event. Before I request today's chief guest and speaker to start his talk, I request Engineer T. Venkatesham, the FIE Joint Honorary Secretary, Telangana State Center, and the convener of the event, to kindly introduce the today's chief guest and speaker, Dr. MVSS Giridhar Garu. Thank you, one and all. Thank you. I request T. Venkatesham Garu to kindly introduce the today's chief guest.
Thank you, Chairman Garu. Good evening and welcome to all on the occasion of Engineer V. Subbarao Garu 5th Endowment Lecture. Respected Chief Guest and Speaker, Dr. MUSS Giridhar, FIE, Professor and Head Center for Water Resources, Institute of Science and Technology, JNTU, Hyderabad. Engineer Brahmareddy Garu, FIE, Chairman, IEA, Telangana State Center. Dr. G. Venkata Subba Garu, FIE, Honorary Secretary, IEA, TSC. Past Presidents, past Chairman, Council Members, Joint Honorary Secretaries, Committee Members of IEA, TSC, Corporate Members of IEA, Family Members of late Engineer V. Subbarao Garu, media friends, ladies and gentlemen, and especially congrats to gold medal of this Subbarao Gari 5th Endowment Lecture Sandarbhanga gold medal to Kasi Suteja, and once again congrats to his parents also. Good evening to all. It is a great pleasure for me to introduce the chief guest and speaker to the elite participants. He is going to talk to us deep learning applications in agricultural remote sensing on the occasion of our late engineer M.V. Subbarao Garu Endowment Lecture. This is a subject in which we should all be deeply interested because our great speaker have given lectures at various platforms and inspired innumerable young engineers, ladies and gentlemen. Please join me in welcoming Dr. MVSS Giridhar. He is presently Professor and Head, Center for Water Resources, Institute of Science and Technology, Jawaharlal Nehru Technology University, Hyderabad. He is an academician having 20 years of teaching, research, and administrative experience. Professor Giridhar is expert for his designs on on improvised rainwater harvesting structures and constructed wetland. Professor was awarded 2 national awards and 4 state awards for best conservation of water resources. Professor Giridhar is an expert committee member for HMSSSB regarding the STP designs and for rainwater harvesting systems to the government of Telangana. Dr. M.S.S. Giridhar has published 175 research papers in various national, international journals, conferences. He has organized 15 national, international conferences and workshops and training programs. He executed 19 research projects funded by various national and international agencies. So thanks one and all. I request our chief guest and speaker, Dr. M.S. Giridhar, please deliver the lecture, sir.
Thank you, Venkatesham sir, for your good words about me. Just to check, is the audio is audible?
Yes, sir.
Yes, sir, it is.
Yes.
Okay.
So I'm happy
Yeah, you're audible.
to give a note lecture on the day of Engineer V. Subba Rao, 5th Endowment lecture. I feel it is a honor on deep learning applications in remote sensing, deep learning applications in agriculture remote sensing. And I welcome Brahma Reddy sir, Chairman, Venkatesham, Joint Honorable Secretary Venkat Subba Garu, Honorable Secretary, and the other esteemed engineers, and Gupta sir from JNTU, Shashikant from OU, and all other learned engineers. I welcome all for this today webinar on Engineer V. Subba Rao Garu 5th Endowment lecture on deep learning applications in agriculture remote sensing. So just to check, Brahma Reddy sir, how much time I can take?
At
Half
your
an hour?
liberty, 45 to 1 hour, sir.
No,
45 to 1 hour.
okay.
Thank you, sir. So earlier, I have a number of times had an interaction with the Institute of Engineers, and thank you so much for giving the opportunity to be before you in front of the esteemed engineers, worked a lot for the government of Telangana and in the area of engineering field. I used to take lectures on rainwater harvesting, improvised rainwater harvesting for rural area as well as urban area, and on water conservation, water management, and stormwater management in the point of sustainability with respect to the sustainable development goals as per the 2030 guidelines, more concentrated towards sustainable water resources. And today I'm moving a little away from that and trying to apply new techniques, new technology in the area of remote sensing, hyperspectral remote sensing, and deep learning.
Excuse me, sir.
In the area of agriculture.
Sir, your screen share about less, sir.
Okay, I'm not started sharing anyway. So today we'll be discussing on deep learning applications in agriculture remote sensing. So
Yes.
when we started working with the water, the rainwater harvesting, the surface water and groundwater, we were testing the water quality, the underground aquifers, both in confined and unconfined. We also started testing water quality on the surface water in the rivers and ponds, especially in the urban area. And in the rivers, there are various places where the chances are pollution. And we found there are a lot of change. Trend is increasing in terms of pollution with respect to the water quality. That is with respect to the physical, chemical, biological, and heavy metal contamination in the water quality. And this water quality, water is in line, touching with all the time with the soil. So some of the parameters enters into the soil properties, and vegetation is growing in the soil. So these roots will uptake the various parameters, greater water quality parameters with respect to the physical, chemical, biological, and heavy metal contamination that is coming as a residuals in the agriculture production, maybe with the curry leaves or with the agriculture production in paddy, where we grow with the fluoride water, or fluoride concentration is more than 5 ppm, 6 ppm. This water gets touched with the soil, interacts with the soil, and when we started growing the agriculture, then the fluoride may be residuals in the form of a paddy production, or in maybe sugarcane production, or in other various vegetables. And we're trying to find out the nexus between the soil, water, soil, and vegetation. This is the major idea of working. One of my students, I'm acknowledging my PhD students, Dr. Soumya and Shama Mohan, working since last 6 years in the area of to find out a nexus between the water, soil, and vegetation. But all of us knows soil varies from place to place, and various types of soils we have. And by assuming a same soil, there may be variety of crops. And in the variety of the crops, suppose it may be a vegetables, it may be a paddy, it may be sugarcane. In paddy also, we have a number of various types of paddies, more than 43 varieties we tested in our study. And these all changes grow with the various varieties of water, means is a huge data is available. And over and above, there are satellites are available in the sky, which is sending a lot of remote sensing data about the crop growth. And we're trying to find out the yield from the remote sensing images using multispectral or using the hyperspectral. This huge data is available. When you are trying to handle these huge data, many times we are feeling a lot of difficulty without the support of the advanced technologies like machine learning, deep learning, and artificial intelligence. So now we started working to handle these huge data with respect to the water and its quality parameters, with respect to the various types of soils and soil behavior with respect to the soil moisture, and various types of vegetation, various types of agriculture crops growing in the soil with respect to the soil moisture. It changes a lot. We're trying to find out the spectral signatures, how it is behaving with respect to the various soils, with respect to the various varieties of the crops and various stages. And finally, we're trying to find out the yield from various varieties of the crops, varieties of the various types of the crop. Suppose if you take paddy again, I found it is a 43 varieties of the paddy we have selected, and we're trying to find out. In fact, estimating yield is not the presently we are doing. Agriculture department was doing since hundreds of years. But as we know, because when you are trying to estimate the yield of a paddy, there is a 43 varieties. So they may be taking a sample of the area and calculate what is the quantity of the paddies coming or vegetables are coming in terms of brinjal, tomato, then multiplying with the area total yield they are calculated. In the process, it is taking a lot of time. Sometimes it may be less accurate. So these advanced technologies, starting from remote sensing, hyperspectral remote sensing, then using all these data sets, satellite data.
Slides move over, sir.
Yeah, yes, sir. I not started moving. It's only just an introduction, overview of the.
Sorry, sir.
So like various images, and we have collected the ground truth data for varieties. We developed the spectral libraries. We developed the spectral libraries for each and every variety of a crop. Which type of a crop, variety of a crop in that, with different types of soil moisture. These are huge data sets. These data sets we're trying to analyze using the deep learning techniques. That's the overview of the deep learning applications in agriculture remote sensing. So this is what it is happening. So it is a it is a various crops is there, various types of water we are giving. In the water, there may be varieties of the pollution with respect to the physical, chemical, biological, and heavy metal contamination. These all we are trying to find out at ground, and using the satellites, we are calculating and we are identifying with various spatial, spectral, and temporal information detection. Then at a ground, we are preparing the hyperspectral images, spectral signature curves, and we are also taking with the hyperspectral sensors, we are preparing the hyperspectral signature curve. These all data will be processed using the deep learning techniques. There are various deep learning techniques. We tested 3 deep learning techniques, and finally we can go for making the decision for agriculture management. So this my presentation today is little more technical when compared with the earlier presentations, like on rainwater harvesting, water conservation, sustainability, and all. This is also useful to the agriculture, and it is in need of our. This is what I'm trying to explain. So this is the spectral information, spatial information, and we get the image from the satellites, maybe with respect to multispectral and hyperspectral, then we'll fix all and we validate, calibrate it, and we validate it. Various pixel level classification, scene wise classification. Finally, we validate with the spectral signatures developed from the ground truth. So the need of the hour is to find the relation between water, soil, and vegetation, because water is getting polluted. From that, the soil is getting polluted, and vegetation, when growing in the soil, it uptake the lot of pollution from the root zone system, and that is coming into the food chain. So we need to find out what is that relation. So to find out, we need to use the advanced techniques, starting from remote sensing, hyperspectral remote sensing, and deep learning techniques. So this is the flow of presentation. I'm trying to touch upon the fundamentals of remote sensing. So because there are students also available, MTech students. So we'll touch basic on remote sensing, then applications of remote sensing, then introduction to agriculture. This is all Indians we know. Deep learning and application in the field of agriculture. Then we're taking a case study and how hyperspectral remote sensing can be used for calculating or estimating, assessing the crop yield. And finally, we'll conclude that. So this is the elements of remote sensing all of us knows. So it is a very basic passive remote sensing. So it uses the sun energy and it interacts with the surface, objects available on the ground, and again it interacts. So when it is touches the ground, we say it is incidental energy. Some of the energy will be reflected back, some of the energy will be absorbed. Depends on the what is the element available here. If it is a road, CC road, maybe 100% may be reflected. Where what we say generally it is a white body. If it is a water, it absorbs everything. We say it is a black body. So the reflectance from the objects is in the range of 0 to 1. This is very, very important in the remote sensing subject. We need to understand. The reflectance varies from 0 to 1. All objects available on the Earth's surface, the reflectance varies from 0 to 1 only. So once we know what is the reflectance coming from each and every object available on the element, based on the reflectance, without seeing the site, we can say that this may be the object on the element. So this is the crux of the entire research. So whatever it is collected at the satellite, it may be lying at 1,000 kilometers away from that surface, 36,000 kilometers away from that surface, and it will send to the local station, receiving station, Earth receiving station located at Shadnagar, and some corrections will be done, instrumental corrections, and all. I'm not going into the details of it. Then it will be sent to the NRSA for further processing errors. So finally, image will be available for us various levels. So if we want to do research, we have to take the raw image, then we have to do the research. If we want to go for application point of view, directly we can take the processed with the geocoded image can be taken and we can do further application. So these are the some of the application. It is what process of remote sensing, pictorially, how it reacted, how much it is reflected. So this is what it is. Then it's sent to the signal to the Shadnagar reception and processing station. It is the final image available for the users for their analysis. Mostly we work initially in the area of nanometers 400 to 700. Now we are working in infrared and in little microwaves, microwave remote sensing. And 400 to 480, 540, 580, this is the bandwidth. So initially in multispectral, we say it is in 3 bands, blue, green, red. So it is a 400 to 800 or 500, maybe one band, 500 to 600, another band, 600 to 700, another band, 3 bands in the visible spectrum. Or it may be further divided after development of 4 or 5 years, it's gone 6 bands, 7 bands in there. So this is what we say it is a multispectral remote sensing. Then we understand that the scientists found that if the bandwidth reduces small, then reflectance will be more. And based on the reflectance, we can identify the variety of a crop and a type of a crop. With that reason, it's hyperspectral remote sensing started. Instead of taking a 400 to 500 is a 1 band, generalized band, they gone for 400 to 401 is a 1 band, 400 to 402 another band, 400 to 402 to 403 another band. Each 1 nanometer or 5 nanometer is 1 band. Then reflectance will be very effective and we can identify the object very clearly. If you use the remote sensing, we can say that earlier multispectral remote sensing, we can classify various types of a crop like agriculture, horticulture, like that. But if you use the Hyperspectral remote sensing, we can identify type of a crop. It is a paddy, brinjal, tomato, and in the type of tomato, we are trying to find out what type of variety it is, what stage it is. That's what it is, hyperspectral remote sensing. The hyperspectral remote sensing sensor nowadays available in the market is 200 to 300 bands. 200 to 300 bands divided between 400 to 700. Started from 3 bands and we are moving to 300 bands. So when we want to work with the 300 bands, we need to have a sufficient technology to work with that. This is what it is, how reaction happens. This all of law of conservation of energy. It is a sum of reflectance, absorbed and transmitted energy. So I'll skip some of the basics. This is what it is, a spectral signatures. Varies, this is the reflected energy. Based on that, you need to identify a type of a element available on the surface. This is how reflects with the water. This is how reflects with the soil or vegetation. This is how reflected with the soil. This is how reflects with the rocks. So this is the standards given, but it is only vegetation is given. But vegetation have varieties. Maybe paddy, maybe tomato, maybe brinjal. So we need to develop if vegetation for various varieties and various types of libraries, like which is available for the vegetation only. So similar spectral may come, but may vary with respect to the peak or valley. That we need to identify. If we identify that, we can identify what type of crop it is. So our idea is we are working on the soil, working on the water, working on the vegetation, and we trying to identify various spectral signatures for various varieties of the crops, soil, and water. So applications of remotes can be applied with agriculture, water resource management, watershed management, urban planning, forest management, land resources, soil resources, mineral resources. Initially, we started with agriculture to find out the nexus between the water, soil, and vegetation. So this is what we discussed. Multispectral remote sensing is based upon the use of several broadly defined spectral regions less than 20 bands in that region, 400 to 700. That's what it is, a multispectral remote sensing. It is a generalized band, not a specific narrow down band, or it is a wider band. Hyperspectral remote sensing is based on examination of many narrowly defined spectral channels, generally 200 bands or more. So this is what it is, hyperspectral remote sensing. So hyperspectral remote sensing may relatively narrow bandwidths, maybe 5 to 10 nanometers, whereas multispectral data sets are usually composed of about 5 to 10 bands of relatively large bandwidths, 670 to 400 nanometers. So that is the main difference in the remote sensing and multispectral remote sensing and hyperspectral remote sensing. So then because hyperspectral remote sensing is having 200 bands, 300 bands, so maybe you need to apply now, you need to go for a artificial intelligence techniques or deep learning or machine learning. We started with the deep learning initially in the field of architecture. So this is what it is, a artificial intelligence, machine learning, then deep learning. Deep learning is a subset of machine learning in which artificial neural networks adopt and learn from vast amounts of data. Because we are having huge data sets derived from the hyperspectral data on the vegetation, on the soil and water. We are not much work done on the water, but we have done more work on the vegetation initially, now working on the water also now. So this is the deep learning uses artificial neural networks to perform sophisticated computings on large amounts of data. So this is very useful. Industries such as agriculture, healthcare, e-commerce, entertainment, and entertainment commonly use these deep learning techniques. And by studying the review of literature, we found there are 12 types of deep learning techniques where we can apply in the agriculture, but we tried 3 deep learning techniques in the present scenario. So it is a neural network is structured like the human brain and consists of artificial neurons, also known as nodes. These nodes are stacked next to each other, the 3 layers in the initial input layer and output layer, almost a black box. In between, you have hidden layers. As much you increase the hidden layer, the efficiency goes on increasing. This is how it is, input and output, the transfer function in between, where engineers need to play a role, and we need to define and we need to calibrate it, validate it in such a way that we need to get an expected outcome. So that's what it is, deep learning. Deep learning can be applied in various applications to identify in the agriculture. So this is what it is, a deep learning. So provide the neural network. So we need to go for a data collection, then data preparation, then choosing the learning algorithm, trying the model, evaluating the model, and finally predictions. This is the flow. Once this is done, whatever may be the data, huge amount of data, then we can feed into the system and it will give the predictions. If the predictions are not matching with respect to our ground truth data, then we have to modify it, train it, and again calibrate the data, then go for the validation. This is what it is: a data collection, data preparation, then train the model, evaluate the model, finally we will predict the model. So there are various factors: deep learning and machine learning theoretical comparison. So we are not entering into the machine learning, we are working only in the deep learning area. So these are the various types of deep learning, and we started working with the CNN. There are LSTM, RNN, GANs, RPPNs, MLP, SAMs, DBN, RBMS, autoencoders. So all deep learning algorithms are used different types of neural networks to performing specific tasks. I'm not going into the deep technical details into the ANN. We're trying to apply, and we're trying to apply for agriculture, and that part only I'm trying to show here. This is what we discussed. So deep learning applications in the agriculture, it is for the crop yield estimation, and we can also identify the plant disease identification and soil moisture content determination, soil moisture prediction, nutrient deficiency detection, weed classification. We initially started working only with the crop yield estimation, and this also can be applied in the deep learning. But we'll be presenting in our talk is a crop yield estimation using hyperspectral remote sensing. So this is the deep CNN as deep learning solution agriculture. What type of different type of architecture it is available? We are not going into high technical details into that. For plant disease identification, how we can apply crop yield estimation, how we can do it, is all we are given it. Soil mapping, how we are done. We have done the literature collection, but we have worked up to crop yield estimation using that. So the literature says is a crop yield estimation we can estimate 99.6% accuracy. We have not reached up to that, but with using the deep learning and hyperspectral remote sensing, we can estimate the crop yield estimate with accuracy of 99.96 if the model is accurately trained. And plant disease identification 98.9%, plant disease identification 95%, real-time tomato disease and pest identification 86% by using various deep learning architecture. So these are the additional applications of the deep learning in the future. So maybe fruit counting, plant species identification, weed classification, plant cover classification, precision agriculture irrigation, nutrient deficiency detection. These all can be applied in the deep learning application, but we're in the initial stage of all this. So we're taking a case study for using the hyperspectral remote sensing based crop yield estimation. So this is the conventional method how we do. So they go for each and every place and take a small area in that particular village. The Mandal Agriculture Officer, Mandal Agriculture Extension Officer, AEOs, then they calculate in that small acreage what is the yield in a controlled environment, and then multiply that yield with the total area, we get the total yield. Sometimes it is a unreliable, leading to inaccurate crop acreage and yield forecast. So this satellite technology definitely will augment to improve the crop acreage estimation and yield estimation further. So these are the basic objectives, and we have taken a study area, Chevella Mandal, where the various types of vegetables like cotton, paddy, various types of agriculture crops, cotton, paddy, bajra, carrot, tomato, mirchi, and maize. And again, in the further classification we have taken. So these are the various villages, almost 36 villages in our study area. And this is the map of the Chevella Mandal. And this is how we have taken the spectral signatures for water and vegetation in the visible and other areas. So these are the spectral signatures we have. Spectral signatures, we need to find out what is the peak and valley configuration that for each and every variety of the crop. Development of the precise spectral libraries of various vegetation or crop types and their species gathered at various phenomenal growth stages is one of the primary requirements to make the fullest use of tremendous strength of the hyperspectral data. So that's what we tried here to develop the spectral signatures for various stages. So this is the spectral signature. Again, I'm not going into detail of that. So we can compare the hyperspectral and multispectral. So you can find out the difference. What is the difference between hyperspectral and multispectral? This is the multispectral, generalized one. This is the hyperspectral, gives clarity. And this is the detailed methodology. done in the research. So data acquisition, then ground truth data, collect the data from the agriculture department, use the satellite data from USGS, Earth Explorer, freely available. That process is use the software, NV, use the SAM, then identify the crop, give the attributes, pre-classification statistics, identify the crop signatures, then crop acreage, convert acreage into acres, then finally validation and estimation. Because of the paucity of time, I'm not explaining each and every box, but this is the overall arrangement, and finally we'll get the acreage estimation. From that we can find out the yield estimation. So this is how it is a ground truth. Ground truth we collected for the spectral signatures, and we have taken the agricultural statistics for validation. And we have taken satellite data for various years, almost 20 years satellite data we have taken, and we worked with that. So initially we started developing the spectral library. So to identify the spectral library, so we need to identify where the crops are grown in a controlled environment. So we selected the Rajendra Nagar Agriculture University, where they grow varieties of the crops with the given fertilizers and pesticides, known what is applied in a controlled environment, and we try to develop the spectral library for each and every crop. So spectral signatures are different for different types of soils, and spectral reflections curve of a bare soil is considerably less variable, and as the soil moisture changes. So this is for the vegetation. Then we try to identify the soils. So how it changes with respect to the moisture content, soil structure, surface roughness, presence of iron oxide and organic matter. So it is a soil moisture content is strongly related to the soil structure. All of us knows. We are trying to prepare the spectral signature. See, with the change of the sandy soil, it the 0%, 0.1% moisture content change with respect to the sandy soil, red soil, and black cotton soil. Suppose if I get this is the spectral library data collected with the moisture of 0.1% for various types of soils. And if I get the hyperspectral remote sensing data taken from the satellite, if that signature shows relatively nearer to this, then I can say that maybe the black cotton soil with a 0.1% moisture, relatively nearer to the accurate. Then red soil, this is how it the spectral signature. This is the library. This we need to compare with the data generated from the hyperspectral remote sensing satellite data, and for a bare soil, so we can find out this for the sandy soil. So this almost these peaks and valleys are matches, but there may be change with respect to the magnitude of the peak or valley based on the percentage of the soil. This is what we understand from the ground truth data with the ground-based spectral signature library. And this is for red soil for various soil moisture conditions. Earlier we have seen for moisture content 0.1% for different soils, black, red, and sandy. Now for the ones of red soil, and these are the various soil moisture conditions. So this is very, very useful in the precision agriculture. This is very, very useful in the precision agriculture. By seeing this, we can say that this may be the percentage of red soil with 11.2% of the moisture content. So this curves indicates, we discussed already, these peaks or valley changes. Peaks and valleys are same, but magnitude changes. Based on that, we can identify whether it is a red soil, black cotton soil, or sandy soil, and what is the soil moisture. So we are taking the Sri Konda Lakshman Telangana State Agriculture University, Rajendra Nagar, with the permission from the department, and we developed spectral signature for the entire crop duration for all the crops, where they are grown in the both Kharif and Rabi, and all the data. So this is how the students are going and collecting during the plantation entire crop period, starting from sowing to harvest, how it changes with respect to the initial stage, growing stage, maturity stage, and harvest stage. This is what it is, a instrument spectroradiometer. Using this, we can develop the spectral signatures. And once we fix that it is a spectral signatures are uniform, we need to do some modifications, and there are a lot of procedures, a lot of problems involved while taking the spectral signatures. After considering all that, we need to develop a spectral library for each and every crop, type of a crop, and stage of a crop. So this is the crops and varieties selected for the study. So common name and scientific name, palak, mirchi, paddy, maize, and all the list. And if you see paddy itself is a number of varieties, and maize we have 3 varieties. So tomato we have almost 3, 4, 7 varieties. colocasia, then brinjal. These are the various varieties grown in the agriculture university in the horticulture department. Under the control of horticulture department, we try to collect all the spectral signature entire crop period. This is the first difficulty. It took almost 1 hour, 1 year, 1.5 years to develop these spectral signatures. Then we compare with the hyperspectral data. All this data we can put into the deep learning techniques, and we can find out, we can predict the yield. So these are the spectral signatures of all for various stages. So maybe starting with the initial stage, growing stage, maturity stage, and harvesting stage, how it is varies. So these are the spectral signatures for the initial stage, flowering stage, fruiting stage, and final stage of the different spectral signatures. So similarly for mirchi, chilies, so different varieties. So this is how we are done. Like that, we are done for all varieties of chili, mirchi, and chilies, and all the other. This is for paddy, how it is growing in the initial stage to the final stage. And for all varieties of the paddy, there is a change with respect to the peak on valley. And this is for paddy varieties, different paddy varieties, and spectral signatures of the maize crop, spectral signatures of the maize crop and its varieties, ladyfinger, so for all the stages, so brinjal for all the stages, and varieties of the brinjal, how it is growing, then cluster beans, all the vegetables and crops, all the crops growing in the agriculture university. We took the permission from them, thanks to the permitting the department to enter into their research field and taking the data on the daily basis for the entire duration. Then we have used the software, NV software, and these are the various steps, the processing. So I'm skipping some of the data because it may take more time, already half an hour. So as these are the technical details need to be done, all the corrections. So because it is hyperspectral data, with the bandwidth is very small, need to do a lot of corrections. It may be erroneous data. Use the SAM spectral anger mapper. So this is how we'll get the validation of the crop acreage. So supervised classification image for crop acreage of mirchi, NP60, NP46. So this is it shows where the chilies are grown for the year. And this is for the another crop for the brinjal varieties. You can find out what type of varieties. There may be a little error, 10% plus or minus we found when cross-checked with the farmers in different durations. So this is a brinjal and its varieties, different colors. It shows how brinjal and different varieties. So this is for paddy, different types of varieties you can find out. So once we know what type of variety, it's the estimation of acreage, area, and all. It is easy in the software. Only pre-processing corrections and calibration and validation is the tough task. So we have collected the ground truth using the spectroradiometer and developing the deep learning algorithm. Once the data, after receiving that, then we applied in the deep learning coding. Then finally, we estimated the village-wise crop area estimation for each season, starting from 2019 to 2018. And villages, paddy, but both Kharif and Rabi for all the crops. And what is acreage? This acreage is when I say it is a paddy, it is all varieties of the paddy with respect to the acreage for 2009. And for all the 36 villages, we could able to estimate. There may be little error, maybe 10, 15, plus or minus 10, 15, but sitting in the office, no need to go to the field directly. Once the software is developed, model is developed, only we need to take the data from the satellites and put into the software and the deep learning, then we can find out what is the acreage. So these are the village-wise crop acreage for 2010, 2011 for all the villages. So we also verified with the statistics department what is acreage estimated, because it's a trial run. We need to calibrate and validate the data. Almost more than 80% accuracy we found when compared with the statistics department. So 2012 for all the villages. So here we're only changing here and the remaining all. This is the 2013 for various villages and crops for all the varieties. And 2014, the 36 one. So 2015. And this is the red one is acreage estimated with our model. And this is the statistics from the department. 2016, 2017. Like that we have done for all the years, starting from 2009 to update. And these are the names, and this is the crop acreage. Whatever we have shown here, it is a paddy for all the varieties. Now here it is a crop acreage for various types of varieties of the paddy. This is very, very important, which is not available with the department. So this we can identify by sitting in the office, by taking the images, we can identify what type of crop it is, what variety of the crop it is, and at what stage it is now. That also we can identify nearer to the accurate. Maize and tomato, how many types and what is its acreage. Like that, it's a on a particular year, this colocasia crop is not there. That also we can identify. And we can also compare what is the crop acreage in earlier years and what is the crop acreage now. We can all compare all this. So we need to validate. We are taking the statistical support for validation, mean absolute error, mean square error, and root mean square error, and regression analysis carried out for all the data. So and found these are the observed and estimated crop acreages using the Python script. So this is for different varieties, different years, you can see. So finally we estimated the yield. So we estimated paddy is estimated tons per acre, average estimation for the entire area. Tomato is estimated 16 tons per acre, which 3 tons per acre, brinjal 14 tons per acre, cluster beans 5 tons per acre, palak 3 tons per acre. Like that we could estimate, and this all in the program code, the Python regression analysis. That's all from my side, sir. Venkatesham, sir. So any suggestions? Any queries?
Any questions from our dignitaries, sir? Okay, Ramana Nagar, please.
Good evening, sir. Professor Saab.
Good evening, sir. How are you, sir? Happy
73
Republic Day to all of you.
73 గణతంత్ర దినోత్సవ శుభాకాంక్షలు మీకు మన యూనివర్సిటీ జేఎన్టీ ఉస్మానియా ఎన్ఐటి కాకతీయ భూలోకంలో ఉన్న అన్ని యూనివర్సిటీలకి సూచనలకు నమస్కారాలు. సార్, it is a very happy, sir, highly appreciable presentation, sir. I think being a son of soil, being a JNTU alumni, being a JNTU former faculty, Delhi liaison officer, and I'm proud of my friend, eminent Professor Dr. Gidhar Saab, FIE. Really great, sir. Proud of you.
Thank you, sir.
Hello. మనం ఇంకా ఎంజాయ్ చేద్దాము. మీ పవర్ పాయింట్ ప్రజెంటేషన్స్ ఎవ్రీథింగ్ హైలీ షూర్ యు ఆర్ మూవింగ్ త్రూ విత్ తెలంగాణ ఏపీఐయు, దట్ ఈస్ తెలంగాణ దేశం యూనివర్సిటీ అండ్ సో మెనీ థింగ్స్. సార్ మీరు ఎంత కష్టపడరో తెలుస్తుంది. వీఆర్ రియల్లీ ప్రౌడ్ ఆఫ్ యూ, సార్. మేము కొద్దిగా లేట్ చేయాలి డ్యూ టు దిస్ వైఫై వల్ల. హ్యాపీ, సార్. అండ్ మరొకసారి మీకు అవకాశం ఇవ్వాలి, సార్. ఈజ్ రియల్లీ గ్రేట్ టాపిక్, సార్. థ్యాంక్ యూ టు కన్వీనర్ గారు అండ్ చైర్మన్ అండ్ ఐఐటి మన ప్రొఫెసర్ డాక్టర్ ఎంఈఎస్ఎస్ గిరిధర్. ఎఫ్ఐ రాదు సార్, మీరు ఎఫ్ఐ పెట్టుకోవాలి సార్. ప్రొఫెసర్ గారు ప్లీజ్ పుట్ ఎఫ్ఐ. థ్యాంక్ యూ. వీఆర్ రియల్లీ సన్ ఆఫ్ సాయిల్ గా మేము ప్రౌడ్ ఆఫ్ యువర్ టాపిక్. థ్యాంక్స్.
గిరిధర్ గారు ఒక్క నిమిషం అండి. గిరిధర్ గారు, మనకి ఈ అప్లికేషన్ ద్వారా మన క్రాప్ ఇన్సూరెన్స్ సంబంధించి క్రాప్ ఇన్సూరెన్స్ రైతులకి క్రాప్ ఇన్సూరెన్స్ కి మన ఈ అప్లికేషన్ ఏ రకంగా ఉపయోగపడుతుంది
సార్? ఇప్పుడు ఇది ఎవిడెన్స్, సార్. రిమోట్ సెన్సింగ్ డేటా అంటే ఎవిడెన్స్. సో దే కెన్ షో దట్ ఇట్ ఈస్ ఏ బిఫోర్, ఇఫ్ ఇట్ ఈస్ ఏ ఫ్లడ్ ఈవెంట్ అకర్డ్, బిఫోర్ ఫ్లడ్ మా క్రాప్ ఉంది, ఫ్లడ్ వచ్చిన తర్వాత మాకు క్రాప్ పోయింది అనేది ఈజీగా చూపించవచ్చు. సో హౌ మచ్ ఎకరేజ్ ఇట్ ఈస్ డ్యామేజ్ బికాస్ ఆఫ్ ద ఫ్లడ్స్, బికాస్ ఆఫ్ ద మేబీ వడగళ్ళ వల్ల కానీ, ఫ్లడ్స్ వల్ల కానీ, ఏదైనా ఫెస్ట్ వల్ల కానీ డ్యామేజ్ అయింటే మనకి ఇట్స్ ప్రూవ్ విత్ ద రిమోట్ సెన్సింగ్ ఇమేజెస్.
అయితే ఎప్పుడు అది యాక్చువల్ ఫీల్డ్ లో జరగట్లేదు కదా. ఫీల్డ్ లో క్రాప్ ఇన్సూరెన్స్ అనేది మాకు రావట్లేదు అనేది రైతులు గోల పెడతా ఉన్నారు.
ఇప్పుడు ఎవిడెన్స్ ఉంటది కదా సార్, రిమోట్ సెన్సింగ్ ఇమేజెస్ తీసుకుంటే ఎవిడెన్స్ ఉంటుంది. అంతకుముందు అయితే ఎవిడెన్స్ ఓన్లీ సర్టిఫైడ్ బై మన డిపార్ట్మెంట్. ఇప్పుడేమో నౌ ఇట్ ఈస్ ఎవిడెన్స్. సో బిఫోర్ ఎనీ డిజాస్టర్, what is acreage, how it was, and after disaster, how it is damaged, how much, what is the total acreage.
అయితే ఎందుకు రైతులు దీన్ని వాడుకోలేకపోతున్నారు?
ప్రభుత్వం వాడుకోవాలి, రైతులు వాడుకుంటారు.
అంటే రైతులకు కదా కావాల్సింది డబ్బులు.
అవును,
ఇన్సూరెన్స్ డబ్బులు రైతులకు కదండి కావాల్సింది. ఎక్కడుంది లోపం? ఎక్కడుంది?
Nando sir, when Chandrababu was chief minister, there was a touch screens was there. Grisa చెప్పినట్టు ప్రభుత్వంతో పాటు రైతులు కూడా బాగానే యాక్టివ్ అయ్యారు సార్. కొద్దిగా దీన్ని మనం కొద్దిగా హైలైట్ చేయాల్సి వస్తుంది ఆర్ఎండ్లో.
ఆర్ఎండి కాదు బాబు, ఇన్సూరెన్స్ డబ్బులు రావట్లేదు.
అది కూడా సార్
మాట్లాడతారండి నీకు దీని గురించి అడుగు.
Insurance is different and R&D is different. Insurance part is when the farmer, the crop goes or something happens. How that insurance will be taken? That's what he is asking. Our Dr. Narayan Rao garu.
నారాయణ రావు గారు, యాక్చువల్ గా సార్ రైతు మీద ఇన్సూరెన్స్ అని ఎందుకు వాళ్ళు ఇన్సూరెన్స్ ప్రభుత్వం చేయించాలి సార్. అది వాళ్ళు అసలు ఇన్సూరెన్స్ చేయదు కాబట్టి ఈ రిమోట్ సెన్సింగ్ డేటా తీసుకోవాల్సిన
అరే ఇన్సూరెన్స్ చేశారు బాబు. ఫర్ ఇన్ఫర్మేషన్ 90% ఫార్మర్స్ ఇన్సూరెన్స్ చేస్తున్నారు.
1 minute, insurance is automatically done by if loan is given, bank takes care of it, bank deducts the amount from the loan amount and they do the crop insurance. And what you are asking is how that is applicable by this one, whether it can be done. That is what I understand.
అదండి, అది కరెక్ట్. దానికి గిరిధర్ గారు చెప్పండి.
We use the GIS technique.
Can be done, and here the subject was a deep learning, how the crops and all that. Yes, known as by using the water resources for the crop development. In fact, I think if the artificial intelligence is applied, what you said is artificial intelligence is important to apply to the agriculture so that the crop insurance also covers in that part of that. So, sir, Giridhar sir.
So we can use the GIS technology and we can prepare the land records and we can integrate that layer with the remote sensing data and we can identify which area is damaged and we can link with their bank accounts. If it damaged directly, it can be given to their bank account also. We have a sophisticated system with the GIS layers.
Artificial intelligence. Disease.
Ayodhya Kavita Reddy, some raise her hand. Please let her ask the doubt.
Yeah.
Ayodhya Kavita Reddy, please.
Yeah. Good evening, sir. Giridhar sir, it was really a great presentation. Sir, I have a small doubt. Like, will this AI system will help in understanding the extension of the damage that has got to the crop?
Yes, madam. If you have the layers, if you have the we need to have a GIS layer consist of who is the owner for a particular land, and take the image before the disaster, take the image after the disaster, which area is damaged and who is the owner that. It is a very simple software. We can, once data is available, we can prepare in the GIS model.
Oh, no. What I want to know is extension ante ippudu manam we say that the extension, the damage is heavy or minimal. Can we know that?
Yes. We can know.
Yeah. And also, sir, I want to know, probably you would have told or I missed that whether as we are taking the GIS system, can we know which type of a crop it is or only any type of a crop? Only it will say that it is an agriculture area, or will it specify which type of a crop it is?
Madam, GIS only takes the layers. So we need to give the layer. Layer 1 may be owner of that particular area. Layer 2 may be taken from the hyperspectral image, what type of a variety and crop of it, what stage of the growth before disaster, after disaster, really how much damage.
So can we, or
It is
can
a
we
three
at least
layers.
try to do whether, like for example, as we say, it is a reflection of light. Now, each crop, for example, if it is a vegetable crop itself, when we say tomatoes or brinjal or anything, the reflection of light, the absorption of light, and the reflection will vary from crop to crop, whether it is, if it is a fruit or if it is a vegetable. Can
Yes.
we also make it applicable to the type, to analyze which type of a crop it is?
Yes, madam.
Oh,
Yes.
yeah. Oh,
You
thank
can
you,
do
sir.
it.
Thank you, sir. It was really very much useful, and it was really a step ahead in the agriculture field. So, congratulations, sir. Thank you, sir.
Madam, it is only the initial stage. We need to do a lot
Okay.
of research and we
Yes,
need to
yes.
build in the precision agriculture. These all inputs.
Yeah, really, application of AI in agriculture. I think this will boom up our agriculture field, and also understanding what type of work we are doing in agriculture.
Yes,
Nice
madam.
talk, sir. Thank you, sir.
You are 100% correct.
గిరిధర్ గారు ఈ 32 విలేజ్ కాకుండా మొత్తం రాష్ట్రం మొత్తం మీద జరుగుతుందా లే ఓన్లీ మీ
లేదు ఓన్లీ మేము చేవేళ్లలో ఉన్న 36 విలేజెస్ మాత్రమే స్టడీ చేసాం. So
దిస్
once this
అప్లికేషన్ ఇస్ నాట్ ఎక్స్టెండెడ్ టు ఆల్ అదర్ విలేజెస్.
No, sir, we're not extended. We are done only for the 36 villages. We can extend it, but for that we need to procure a lot of data. It require finance and to
Finance required కదా.
Yes, sir, that is all. Need a lot of time for analysis.
చెవెళ్ళ ప్రొఫెసర్ గారు,
Sir,
ప్రొఫెసర్ చెవెళ్ళ ఏ విలేజ్ పేరు కొన్ని
36 villages, sir.
He has already given the list, sir. You can
Yes, I
kindly.
given the list.
థ్యాంక్ యూ.
All the 36
Professor.
villages.
And Mr. Seshikant is raising a hand. You can talk.
Yes,
Yeah.
yes, sir. Any suggestions?
Sir, good evening, sir, for giving the opportunity.
Good evening, sir.
Professor Giridhar Garu, a very nice presentation on a good
Thank you.
topic, deep learning in agro products. I really liked it. Many congratulations for taking up that product. But only thing, sir, when you're talking about deep learning, how many years of data you have taken?
It is in CNN. We modified it, sir. Initially, we started with 30 layers, and we modified finally till we get the predictions. In fact, that deep layers and all, I'm not involved fully. Scholars has done that work. We are concentrated only on the outcome efficiency.
Sir, assuming the relation between the yield of a crop, okay, the yield of a crop depends on following factors, no, sir?
Number of factors.
Number of factors, very good. So what actually factors you have considered while framing the deep learning process?
So this time, this work we have started working using the deep learning for classification of various types of crops and varieties of the crop. Then
Okay.
after estimating the acreage, we are taking the average yield from the department and we multiply it. Still, we need to do a lot of, because yield involves number of parameters. So we have not done that part, sir. We have calculated the acreage multiplied by average yield collected from the local area.
Yeah. Whether you did village wise or whether you did for watershed, because village
Village-wise, sir, village-wise.
that's really very,
Village-wise.
I mean, thoughtful idea. Doing it for village level, I think needs a lot of information about the crop, what is being grown at each village. I think
Yes,
you
sir.
have done a very hard work going to each and every place, getting that information, and including soil moisture data also. You might have taken it. It's
Yes,
a big
yes.
task. Anyway, I think you have done well.
Sir,
Probably,
most of the, sir, sessions, most of the work done by students only. We are only guiding, and after getting
Okay,
the data,
okay.
we are collecting and guiding them to test
Correct,
the
correct.
quality final results. Most of the data
Yeah, yeah.
students, MTech and PhD students collected from the field.
as you might be knowing, sir, when you are framing deep learning during calibration, suppose you have developed a relation during calibration, right? And you're also going to predict, is it not, sir?
Yes, sir.
So suppose in future, if there is no proper rainfall, as people are talking about insurance, so probably now implementing that insurance, because if there is no proper rain or like soil moisture is not properly there, probably it would be difficult. Probably you need to consult climate change experts like us, so that we'll be able to give a solution for that. Probably
Yes, sir.
that's probably insurance aspect could be taken up. I mean, this is my thought process, sir. And thanks for the opportunity.
So what we have done is soil moisture we have taken for various stages of the crop. And if the soil moisture is less than the field capacity or less than the wilting point, that also we noted, but we not directly linked with the climate change. You are the climate change expert. So definitely we'll take your suggestions and help in adding the climate change parameters also into the model.
Sure, sir. Thank you. I'm ready
Thank
to
you.
help you because I worked in climate change. So
Yes.
I'm really can help you. Thank you.
Yeah, thank you. Thank you.
Anybody else? Please?
Shashikant is over, sir?
Yes, sir. I'm done, sir. I'm done.
Okay, okay.
1 minute. I think nobody is there. No other question. Thank you. Pragmatic and experimental topic which you have applied to agriculture, sir. And I hope and also wish in the future we will develop using the artificial intelligence in toto to this agriculture so that farmers will be highly benefited by detecting in the pre-detection of the diseases, thereby saving the crop, so that the crop insurance question may not arise, because if the crop is saved and if the crop comes, insurance may not come. But however, as our Dr. Narayan Rao said, I think that part also you should include next time, and in your experiments, how they can be used for helping the crop insurance to the farmers. Thank you. It's a really very, very pragmatic, wonderful lecture. Thank you, sir. I think all the participants enjoyed your lecture and talk. And it's my, I'm glad now. I want to announce, as desired by the Mrs. Ramadevi, wife of late engineer V. Subba Garu, the Telangana State Center has instituted an award to a student of NIT Warangal to his public her cumulative topper of the MTech with first class for over 2 years in water resources engineering batch of this time batch is 2019 to 21, and NIT Warangal has informed us that Mr. Kasi Suteja is a person from Medchal of Rangareddy district, has stood the topper of this and has nominated his name to us for this award and this certificate. And all of you kindly, you give me a good clap for this person. Now, Venkatesam sir, you can request this one, Kasi Suteja, to come on the screen, so that, of course, we can't give him physically now certificate, but we'll hand him over as per his choice, either through the post or
Gold medal also, no?
releases to our some other day. We can have a small function time, and we will hand over him the medal and certificate. Now, but we are announcing his name now as per the NIT Warangal recommendation. So he is there on the screen, and Mr. Kasi Suteja, kindly you can appear Mahesh.
Sai, Kasi Suteja,
Please click it.
come on.
Photo will appear to everybody.
Kasi
Share the
Suteja,
video.
welcome.
Yeah, he's available.
Yeah, come on. Just your
Congratulations, and you are requested to appear on the screen, please.
Yeah, he's available, sir. He's
yes. Let him come on the screen, sir. We are not able to see him now. Hello, Mr. Mahesh.
Good evening, sir.
Yeah,
I
okay.
turned my camera on. I hope I'm visible to all of you.
Yeah.
visible.
So congrats,
Yeah.
Sai, Mana Suteja, Kasi Suteja. Congrats.
Thank you very much, sir. I feel very happy to get this. So I thank everyone for.
So you got the medal of Engineer V. Subba Garu. You contact our honorable chairman, okay, in working day. Please come into our institution office. You know, I think Institute of Engineers,
Yes, sir.
you might have known, isn't it?
Yes, sir. I know.
Please come there and take the certificate and along with the gold medal also. Your parents are not there,
No, sir. Not right now.
Right now, okay. What are your parents?
Sir?
Your parents do a government job or any farmers?
Yeah, no, they used to work in bank, sir. Now they retired.
Acha, acha, very good, very good, very good. So keep it up. Now what you are doing after MTech?
Yeah, I'm trying for jobs, sir, right now.
Also, anyhow, in your engineering department, irrigation department, there is a minimum 1,000 jobs will be notified shortly. Okay. So
Okay,
get
sir.
prepared and you become an engineer. First you
Yes,
become
sir.
the member of our IEA. Okay.
Okay, sir. Okay, sir.
While coming to our institution, get your 10th class certificate and degree certificate. Okay.
Okay, sir.
So
Okay,
make
sir.
the membership there itself and take your certificate and gold medal.
Okay, sir. Sure.
Okay. Okay. Thank you.
Okay, thank you, sir. Thank you.
Mr. Kasi Suteja, and many more laurels in your career and in future. From institution of engineers is always helpful to you. Anything, you are always welcome to institution and help of chairman, honorary secretary, or any of the committee members. There are highly qualified professors who are part of our executive committee, and as our joint secretary, you are welcome to join our institute because your career is long, career is ahead. So please use the benefits of the institution. Thank you. And I request
Okay, sir.
Venkatesham Garu to propose vote of thanks.
Thank you, Chairman, sir. On behalf of the Telangana State Center IEA and on my own behalf of, I convey our sincere and profound thanks to Dr. MVS Giribabu, Giridhar Garu, FIE, Professor and Head, Center for Water Resources, Institute of Science and Technology, JNTU, Hyderabad, who delivered a valuable and wonderful lecture, sir. Really hats off, sir. ఎంత క్లియర్ గా మీరు చెప్పారంటే రిమోట్ సెన్సింగ్ గురించి అగ్రికల్చరల్ అప్లికేషన్స్, ఆర్టిఫిషియల్ ఇంటెలిజెన్స్, మెషిన్ లెర్నింగ్ అండ్ డీప్ లెర్నింగ్ అండ్ అసలు ఫ్రమ్ సోయింగ్ టు హార్వెస్టింగ్ వరకు ఈవెన్ క్రాప్ రిక్వైర్మెంట్స్, తర్వాత వెరైటీ ఆఫ్ క్రాప్స్, తర్వాత ఈవెన్ వీ కెన్ yield also we can check by remote sensing, and at the same time even the what is the crop grown and calculations from Bureau of Indian Standards and I'm a Bureau of Economics, and actually your scientific remote sensing really, sir, wonderful, sir. Even ఓపిక్ గా నువ్వు ఆల్మోస్ట్ ఆల్ మీకు 35 minutes టైం అనుకున్నాం సార్, బట్ యు హావ్ అబ్సల్యూట్లీ 37 minutes యు హావ్ టేకెన్ సార్. అండ్ ఓపిక్ గా మీరు అరౌండ్ 14 minutes ఆల్ అవర్ కార్పొరేట్ మెంబర్స్ క్వశ్చన్స్ క్లియర్ గా మీరు ఆన్సర్స్ ఇచ్చారు సార్. వీఆర్ వెరీ ఆన్ బిహాఫ్ ఆఫ్ థ్యాంక్స్ సార్, ఎస్పెషల్లీ యువర్ వాల్యుబుల్ టైమ్. And at the same time, for on the occasion of this Mr. Engineer M.V. Subba, our 5th endowment lecture, the topic is deep learning applications in agriculture and remote sensing, sir. I also thank and dignitaries our past presidents and present chairman and present honorary secretary and council members and joint honorary secretaries and immediate past chairman and immediate honorary secretary garu and corporate members and family members of late engineer M.V. Subba garu and others who made it convenient to attend the event, made it success. I also thank the representatives of the media. Thanks one and all. Once again, Mr. Suteja, congrats on behalf of our institution of engineers, and I wish you all success in your future endeavors. Please, as early as come and you join in our Institute of Engineers as a corporate member. Thank you, one and all.
Thank you, sir.
Hand is raised by Shashikant Kulkarni. Anything you want to say? Kulkarni Shashikant, his hand is raised.
Still is there?
Yes, sir.
There, you should switch off, I think.
Sir, one second. Can I talk, sir?
Yeah, okay, no problem.
Sir, Suteja is our student, sir. Usmania student. He worked
Achha.
under me.
Yes, sir.
Very nice student. Sir,
In
can you hear?
MTech is doing here?
No, sir.
Yeah,
He done
my-
BE from OU.
Acha, acha.
He did BE
MTech
from
from
here. MTech.
NIT.
Yes, sir. MTech from NIT.
Okay, nice, nice.
I'm very happy for him. I think he worked under my guidance.
Oh,
I'm
nice.
happy and all the best wishes to Suteja. Thanks, sir. Thanks for the
Congrats
Okay,
to
thank you, sir.
Shashikant
Thank
also,
you.
to you also, Kulkarni garu.
Thank you, sir. Thank you. Thank you.
Okay, thank you all the members, and for vote of thanks to, because we have to thank the everybody. On behalf of every one of us and IEA and Telangana State Center, I am thanking Engineer Venkateshan Garu. So, Mahesh.
Sir.
Maybe.